Hi there, welcome to this video. This is lesson 1 of unit 3B. We are going to dive into trigonometric functions. So by now you should have a good solid foundation and an understanding of the unit circle, or at least feel comfortable enough in order to go ahead and use it, okay? So lesson 1, we are going to talk about sine, cosine, and tangent values, and we're learning how to solve problems that involve a circle centered around an origin. The radius is not always going to be 1, and sometimes they might give you information about coordinates or an arc. You'll be successful if you know the relationship between an angle and standard position and the point where the terminal side intersects the circle of a given radius, and if you can understand the vertical and horizontal displacement given an angle and standard position that intersects with the circle of a certain radius. So let's go ahead and talk about what we need to know in order for this lesson to be successful. 1. Given an angle measure of theta in standard position with a circle with a radius r centered at the origin, there's a point P where the terminal side intersects with the circle, where the coordinates of P are r cosine of theta times r sine of theta. And so here's a visual of this. We have a circle centered at the origin. I have an angle, and my angle intersects with the circle, and at this point P. We're just saying that the coordinates are r cosine theta, r sine theta. Now this shouldn't be anything too crazy, because in the last unit, right, the unit circle, we said, hey, our x value was cosine theta and our y value was sine theta. So why are we adding the r? Well, in the last unit, we were talking about the unit circle, where the radius was just 1 unit. So r was equal to 1. So it was kind of trivial there. Here, our radius is not always guaranteed to be 1. Okay, so r cosine theta, r sine theta. Those are your x and y coordinates. Now, the slope of the terminal side of an angle in standard position is equivalent to tangent of the angle. If the tangent of the angle is undefined, the slope does not exist. And remember that this point right here, this point location, that slope is rise, which is your y value, right? Slope is equal to y over x. And my y is sine theta, my x is cosine theta, and so our r's cancel and we just get tangent theta. Okay, so that's how you can determine the slope. It's just tangent of whatever that angle is. Now, there is a new equation that's going to work its way in here, and so this is just one of those things that you should just remember. And they say, given an angle theta in standard position and a circle centered at the origin with radius r, the length of this minor arc A, the arc subtended by the angle or created by the angle, is given as A equals r theta, where theta is in radians. So they're just saying, hey, this arc here is going to be equal to r times theta. So go ahead and put a box around that, underline that. That's a formula that you just need to know. Okay, so I would store it somewhere in your calculator notes, and so it's just there for a rainy day. Make a flashcard of it so you can remember it. Okay, A equals r theta. Next, just a reminder, coterminal angles. If two angles end at the same spot, they share a terminal side. They're said to be coterminal. Those coordinates will be the same. And then we're going to talk about just some language that may appear on an AP Precalculus test. That's horizontal displacement and vertical displacement. And it's really, really easy if you think about it. Given an angle in standard theta in standard position and a circle centered at the origin with radius r, the terminal side theta intersects at the circle at a point Q. The distance point Q is from the y-axis is called horizontal displacement. That's this direction here. Okay, so horizontal is left, right. So think about distance from the left and from the right. And so that is just going to be whatever your x coordinate is, r cosine theta. That's horizontal displacement. The distance point Q is from the x-axis is called vertical displacement. This makes sense, right? Because I'm going up. What's the vertical? Vertical displacement. That is your y value, right? You would calculate that with a y value. So that is equal to r sine theta. Okay? All right, that is vocabulary, concept. Let's go ahead and jump into some examples. What are we going to do? Example, the figure shows angle theta in standard position. Here's theta. In a circle with a radius of 3.5. Radius is 3.5, centered at the origin. The terminal side of angle theta intersects the circle at point D. If theta is equal to 3 pi over 4, so here they give us theta, which of the following are the coordinates of point D? Okay, so I need coordinates. Well, x is equal to r cosine theta. So I have to go ahead and calculate this. 3.5 times cosine of 3 pi over 4, which gives us 3.5 times the square root of 2 over 2, and x is negative in this quadrant. So times negative root 2 over 2. Your y value is going to be r sine theta. So again, 3.5 for radius. Theta is 3 pi over 4. This is also root 2 over 2. But this time, y values are positive in quadrant 2. Okay, so that's what we're looking for our answers. It's not going to be A or B. That's discounting the radius. And we're looking for our x value to be negative. Another way to think about this and eliminate answers is just think about this conceptually. You're given the picture, and you can see that point D is located in quadrant 2. So wouldn't you expect your x value to be negative? I'm going to throw away D right away because my x is positive and my y value is negative. So answer here is C. R cosine theta is x, r sine theta is y. Example 2, the angle theta in standard position with the terminal side theta intersects a circle with a radius 2 at point B. Okay? Anytime they give me radius in a problem, I'm underlining it. I'm writing off to the side, hey, r equals that value. Ooh, if theta equals, they gave me this angle. Okay? Usually trig problems, these are like gold. These are the things that you need. You need theta and you need r. Okay? What's the radius? What's the angle? What is the slope of the terminal side of angle theta? What is the slope of the terminal side of angle theta? Well, really here actually, radius is kind of mute. Radius or slope is equal to tan theta, which here we just need our angle, 7 pi over 6. So radius doesn't even really make a play here. Okay. Two ways you can go ahead and answer this. One is to just know what is the tangent value of pi over 6, and I try to explain this to my students by understanding what does the graph of tangent theta look like, y equals tan theta, and I tell them, hey, this is an increasing function, and so the pi 6 angle, that's smaller, right? It's a smaller value than pi thirds, and so this output is going to be square root of 3 divided by 3. If it was a pi thirds angle, it would just be square root of 3. Okay, but since this is the smaller angle, you get the smaller value. That's the way I explain it. 7 pi over 6 is quadrant 3, and so we know that tangent there is positive, right? Sine over cosine. And that's really the other way to do this. That's the other way to do this, is you convert this to sine of 7 pi over 6 divided by cosine of 7 pi over 6. And your pi 6 angle for your y's is negative 1/2 divided by a negative root 3 over 2. So again, you could do this, negative 1/2 times negative 2 over root 3. These cancel, the negatives cancel, you get 1 over root 3, which we know we have to rationalize. Anyway, answer here is B. B. Okay, next example. Consider a circle centered at the origin in the xy plane. An angle of measure pi third radians in standard position has a terminal ray that intersects the circle at point T. They just gave us the angle right there. They say the angle is subtended by an arc of the circle in the first quadrant with a length 30. So what they told me there is A is equal to 30, and they gave us theta. They said pi thirds. They say, what's the radius? What's the radius? So usually when they give you arc, you need that one formula. And that one formula is A is equal to r theta. Okay? So they'll give you two of these three amigos, and you have to solve for the other. So arc is 30. Okay. I know theta is pi thirds, and I have to solve for r. So I'm going to get rid of the pi thirds by multiplying by 3 over pi. 3 over pi. And these cancel. So we get r. Yar. R is equal to 90 over pi. 90 over pi. Do we have that? We do. C. Answer is C. Okay? Okay. Nothing too crazy here, guys. Just a couple of formulas and straightforward math. All right, a couple practice problems here. Please go ahead, pause me for this one. They say the figure shows angle alpha in standard position with in a circle of radius 3.5 centered at the origin. The terminal side of angle alpha intersects the circle at point D. Which of the following represents sine of alpha? It's also, too, important to note they give you the coordinates of point D. Those are important, okay? So go ahead, pause me, try this one. Okay, hopefully you solved this one, and you need they want sine alpha, so that's going to incorporate your y value. Y is equal to r sine alpha. So my y value, 3.3, and that's going to be equal to 3.5 times sine alpha. We divide by 3.5, and you get sine alpha, c. Okay? All right, next practice problem. In the xy plane, two different angles, alpha and beta, are in standard position and share a terminal ray. Based on the information, which of the values could be the angles for alpha and beta? Go ahead, pause me, try this one. Okay, answer is B. They're essentially asking us which of these angles are coterminal. That's what they want to know. So you can draw it. I just like to go based upon the quadrants and know where these angles are terminal, and so a negative angle is going to take us into quadrant 4. 5 pi fourths, well, that's 1 bigger than pi, so we're in quadrant 3, so that's no. On C, here we're in quadrant 4, and then negative 2 pi thirds, that's going to take us into quadrant 3. And then for D, that one's pretty straightforward, quadrants 1 and 2. Answer here, B. Okay. Let's go ahead and look at this next example. They say the figure shows a circle centered at the origin with an angle measure theta radians and point P on the circle. The terminal ray of the angle intersects the circle at point R, and we can see this here. The length of the arc PR is 5 units. Which of the following gives the distance of point R from the y-axis? Oh, this one's a little tricky. Okay, so let me go ahead and first kind of synthesize the information they tell us. They say the arc is 5 units, okay, from P to R. Also, too, what you should pick up on, hopefully, is that the radius is equal to 4. Radius equal to 4. Now, what do they want? They want to know what is the distance point R is from the y-axis. Okay, so where's my y-axis? Right here. So what's the distance from the y-axis? Well, that's going to be this distance right here. This distance. So what do they want? They want x. What is the x coordinate? They're being college boardy and APE about how do you find x? What's your x coordinate of R? So we know that x is equal to r cosine theta, and they do give us r. We know that r is equal to 4 cosine theta. But I don't have theta. They don't give me theta in a roundabout, or they give it to me in a roundabout way. So they give me arc. Okay, so how do I use that? Well, I know that arc is equal to r theta. So I know that 5 is equal to 4 times theta. So theta must be 5/4. Theta must be 5/4. So let's take this and plug it back in here. Sometimes they do that. You're missing a piece of information, but they give you other tools. You have to go ahead and use your critical thinking in order to find that, right? So I get 4 cosine of 5/4. What's our answer? D. Okay? All right. Okay, practice question here. The figure shows a circle centered at the origin with the angle of measure theta radians and point Q on the circle. The terminal ray of the angle intersects with the circle at point W. The length of the arc QW is 1 unit. Which of the following gives the distance of point W from the x-axis? Pause me. Try this one. Okay, this one was very similar to our last example, but now they just kind of switched up the question. They say, what's the distance of W from the x-axis? So that they want the vertical displacement. They want the y value there. So again, y equals r sine theta. They give me r. That's 6. I don't have theta. What's theta? I don't know. Well, they do give me other information I can use. If they give you arc, then if you have radius or theta, you can find the other one. So 1 is equal to 6 theta, divide by 6, you get theta is 1/6. Answer B. Answer is B. Okay, Last example one I have for you, and then there's one more practice. They say the figure shows a circle centered at the origin with the angle measure theta radians in standard position. The terminal ray of the angle intersects the circle at point P. So here's P. And the point R also lies on the circle. Here's R. And they say the coordinates of P are x, y. Thanks for giving us x, comma, y. And they say R is x, comma, negative y. Well, this makes sense, right? I guess they're mere points. You know, they would belong to the same family in the unit circle. They just have opposite y values. Which of the following is true about sine of theta? Sine of theta. Well, you need to remember that y is equal to r sine theta. Now notice theta is just theta. Theta's theta. But looking at the picture, they do tell you that r is equal to 2. R is equal to 2. So I know that y is equal to 2 sine theta. And so what I can do is I can rearrange this equation to find sine of theta. This implies, if I divide both sides by 2, that sine theta is equal to y over 2. Y over 2. So let's go ahead and check out what we got. Sine of theta equals x over 2 because, no. B, no. It's not x, it's y over 2. Okay, I'm liking C. Ooh, and look at D. Okay, so they say sine of theta equals y over 2 because it is the vertical displacement of P from the x-axis to the distance between the original and point P. Okay, sine of theta equals negative y because it's the vertical displacement of R from the x-axis to the distance between the origin and point R. Okay, I kind of get this, but here's the thing. Theta is related to point P. Theta is not related to point R. Not related to point R. So if theta had gone all the way to R, then D would be the correct answer. But here, it's just C. I'm just looking at C. Okay? Sine equals y over 2. All right, practice problem. Pause me. Check your answer here. Okay, on this example, hopefully you got B again, so using the same logic, x equals r cosine theta. So to find cosine theta, I just divide both sides by r, which they give us r. It's 3, so x over 3. So we can rule out C and D. And then we have to just look at the differences between A and B. They both say cosine of theta equals x over 3, but one says vertical displacement, one says horizontal displacement. Vertical displacement is going up and down. That's y values. So it's not A. The answer is B. It's the horizontal displacement of P from the y-axis to the distance between the origin and the point of P. All right, hopefully in this video you learned how to find sine, cosine, and tangent values of a circle centered at the origin with a given radius. Remember, really 3 main formulas you need to know. X equals r cosine theta, y equals r sine theta, and arc is equal to radius times tangent. I guess with maybe a fourth here, that slope is equal to tangent theta. If you learned something in this video, give it a thumbs up. I'll catch you in the next one.